Every year on the 9th of May, Russia stages the largest military parade in the world. Hundreds of thousands of spectators, dozens of foreign dignitaries, a global television audience of hundreds of millions watching Russia display the full spectrum of its military power in a single choreographed 2-hour demonstration. There is one thing that can ruin it. Moscow in May is meteorologically unpredictable. Rain is frequent. Low cloud cover is common. In a parade designed to project power and precision, bad weather is not an inconvenience. It is a failure of the state. So for the last 30 years, Russia has done something about it. Not by moving the parade, not by hoping for good weather, not by building a roof over Red Square, by ordering the sky to be clear. And every year on the morning of May 9th, the sky over Moscow clears. Not because of luck, not because of prayer, because Russia has a fleet of aircraft and a program that can reliably disperse clouds over a major city within 3 hours, and has been doing it so consistently that it has become, in Russian meteorological circles, almost routine. The question is not whether this works. The question is what else it can do. Russia's cloud dispersal program for state events is one of the worst-kept secrets in international meteorology. It has been covered in Russian state media. Russian meteorological officials have given interviews about it. The basic technology is publicly documented. The official explanation is straightforward. Aircraft fly upwind of Moscow several hours before major events, seeding incoming cloud formations with liquid nitrogen, dry ice, or silver iodide. The seeding causes the clouds to precipitate out, to drop their moisture, before they reach the city, leaving clear sky above Red Square for the duration of the parade. Simple, effective, almost boring in its technical description. But here is the question that the Russian meteorological officials never answer in those interviews. If you can reliably clear clouds over an entire major city, on demand within 3 hours, consistently enough to bet the most politically important event of the Russian calendar on it, what else can that capability do? And here is the deeper question that sits underneath that one. Why did Russia invest so heavily in perfecting this technology at far greater scale and reliability than any other country? And what role did artificial intelligence play in taking it from occasional success to reliable operational capability? Russia's cloud dispersal capability did not start as a reliable technology. The Soviet Union began experimenting with weather modification for agricultural purposes in the 1950s, simultaneously with the United States and for similar reasons. The vast agricultural regions of Central Asia and the North Caucasus suffered from hail damage to crops, cloud seeding to suppress hail, triggering premature precipitation before hail-producing ice crystals could form, was the primary civilian application. The military applications were explored in parallel, under classifications that have never been fully lifted. But the core technology, how to reliably get a specific cloud to drop its moisture on command, was developed in the civilian hail suppression program. The problem was reliability. Early Soviet cloud dispersal operations worked perhaps 60% of the time under favorable conditions. Not good enough to bet a state event on. Not good enough for military operational planning. The reliability inflection point came between 2017 and 2021, when Russian meteorological agencies integrated machine learning systems into their cloud dispersal planning. Advance 1, AI wind field modeling. The key to successful cloud dispersal is not seeding the clouds above the target location. It is seeding the clouds upwind, far enough away that they precipitate out before arriving, but not so far that new cloud formation occurs before the event begins. AI atmospheric modeling calculates this upwind seeding zone with precision that human meteorologists, working with traditional models, could not reliably achieve. Advance 2, Cloud Lifecycle Prediction, AI systems trained on decades of Moscow area meteorological data can now predict with high confidence how a specific cloud formation will evolve over the next 3 to 6 hours, whether it will thicken, thin, merge with other systems, or dissipate naturally. This allows operators to prioritize which clouds require intervention and which will clear on their own. Advance 3. Real-time adaptive seeding. Drone-mounted seeding systems, guided by AI atmospheric models updated every few minutes, can now adjust seeding rates and locations in real time as cloud formations evolve. Something that fixed-route aircraft flying predetermined patterns could never do. The result, Russia's cloud dispersal success rate for major state events went from approximately 60% reliability in the early 2000s to what Russian meteorological officials describe carefully as consistently achieving planned meteorological conditions, which is as close as a Russian government scientist will come to saying, "It works every time." Clearing clouds for a parade is a party trick. What the underlying capability represents is something considerably more serious. To understand what Russia's cloud dispersal capability actually means beyond keeping parades dry, you need to think about weather not as a backdrop, but as an operational environment. Every military operation, every airstrike, every airborne insertion, every naval engagement, every satellite reconnaissance pass has weather as a critical variable. Let's trace the chain. Effect 1. The military visibility dimension. Low cloud cover grounds aircraft. It degrades precision-guided munitions that rely on laser or optical targeting. It makes satellite imagery useless. It prevents visual reconnaissance. It reduces the effectiveness of air defense systems that rely on optical or infrared sensors. A military force that can reliably clear cloud cover over a specific operational area, or conversely, generate cloud cover over an area it wants to conceal from enemy reconnaissance, has a form of tactical advantage that requires no kinetic action and leaves no obvious fingerprints. Russia's cloud dispersal program has been publicly demonstrated over Moscow. The same aircraft, the same seeding agents, the same AI targeting systems can be deployed over any geographic area within operational range. The question of whether Russia has used weather modification for military operational advantage, rather than just parade aesthetics, is one that Western defense analysts have been asking quietly for years. No one has produced public evidence of operational military use. The absence of evidence is not evidence of absence when the technology is inherently deniable and the actor is Russia. Effect 2. The agricultural warfare dimension. Russia is the world's largest exporter of wheat. Ukraine, before 2022, was the 5th largest. Together, they supplied approximately 30% of global wheat exports. Weather is the single largest variable in annual wheat yield. A drought year, a late frost, an untimely hailstorm can reduce yields by 20% to 40% in affected regions. A state that can reliably modify weather over its own agricultural regions, protecting its harvests from hail damage, supplementing rainfall during dry periods, clearing conditions for efficient harvesting, has a structural agricultural advantage over competitors who cannot do the same. Russia has had a national hail suppression program, protecting agricultural regions in the North Caucasus for over 50 years. It is the oldest and most operationally mature weather modification program of its type in the world. What AI has done is extend the geographic range at which this protection can be delivered cost-effectively, and improve its reliability enough to make it a standard agricultural planning assumption rather than an occasional intervention. Russian agricultural planners now factor weather modification into crop yield projections in ways that no other major agricultural producer can. Effect 3. The export dimension. Russia has been exporting weather modification technology and expertise since the Soviet era. Kazakhstan, Kyrgyzstan, Tajikistan, all run weather modification programs using Russian technology, Russian training, and in some cases, Russian personnel. This is not purely commercial. Weather modification technology transfer is a form of technical dependency that serves Russian foreign policy interests. The same way Soviet infrastructure projects in developing countries created long-term dependencies that outlasted the Soviet Union itself. A country that relies on Russian technology to protect its agricultural harvests from hail or to supplement rainfall during drought, and whose meteorological scientists were trained in Russia using Russian models on Russian equipment, is not a fully sovereign actor in its relationship with its own atmosphere. That dependency is quiet. It is technical. It is almost never discussed in the political analysis of Russian foreign policy, but it is real. Effect 4. The precedent. Every government is watching Russia's demonstration that a major city's weather can be reliably modified on demand, proven publicly, year after year, in front of a global television audience, has not gone unnoticed. China expanded its program to 5.5 million square kilometers. The UAE built one of the most sophisticated programs per capita in the world. Saudi Arabia, India, Morocco, the United States, all formalizing and expanding programs that were previously marginal or experimental. Some of this expansion is driven by water scarcity, some by agricultural need, some by climate adaptation planning, and some of it, the portion that defense ministries and intelligence agencies track most carefully, is driven by the recognition that weather modification is transitioning from a civilian infrastructure technology into a dual-use capability with military applications that no treaty adequately addresses. Russia proved it works. Everyone else is making sure they can do it too. Here is what I want to leave you with, and it starts with something that might seem small. Russia clears the sky over Moscow for a parade every year. It works. The technology is real. The AI enhancement is real. The operational reliability is real. Now zoom out. Russia has a weather modification infrastructure, aircraft, ground stations, trained personnel, operational protocols, and now AI targeting systems, deployed across a country that spans 11 time zones and borders 14 other nations. This infrastructure was built and justified as civilian agricultural protection and state event support. It is funded through civilian meteorological budgets. It is staffed by civilian meteorological scientists. It is also inherently dual use in ways that no treaty written in 1978 anticipated. Here is what actually surprised me most in researching this video. The most significant consequence of Russia's cloud dispersal capability is not military. It is not the parade. It is not even the agricultural advantage. It is the proof of concept. Before Russia demonstrated year after year that an entire major city's cloud cover could be reliably controlled on a specific date for a specific purpose, that claim would have seemed like science fiction to most defense planners and most governments. After 30 years of public demonstration, it is simply a known capability that other actors are working to acquire. The proliferation of weather modification technology, the reason China has 35,000 engineers, the UAE has its drone fleet, Saudi Arabia launched its national program, and the U.S. Bureau of Reclamation formalized cloud seeding as a strategic tool, is partly driven by water scarcity and partly driven by the same force that drives every arms race. One country demonstrated it works. Everyone else decided they needed it too. The sky over Moscow on Victory Day looks like just good weather. It always has. Next week, the Bill Gates-funded experiment that wants to block sunlight from reaching Earth, deliberately at planetary scale, and the scientists who think it might be the only thing that can still work. It is the most controversial climate intervention ever seriously proposed, and it is no longer purely theoretical. Subscribe. That one requires a clear sky to think about carefully.